Hello and good evening.
Good evening, sir.
Good evening and sorry.
Good evening, sir.
Yeah, good evening. Yesterday we had a sudden break due to the lights. Actually, it's happening for the last 2 days. I'm not able to conduct the seminar, but hope today will not come across such disturbance. That that is what I can hope. Yes or no?
Yes, sir.
Okay, but people are not yet joined. Okay, yeah, Masroor Jan has joined. Good evening, Masroor.
Good evening, sir.
Good evening. Good evening.
I couldn't hear that time, so I left and joined.
Actually, I was also yesterday. There was a disturbance, and light came at something around 9 o'clock. So it was not just can't say that we can carry out. Uh, I was hoping that it might get back at 8 o'clock, but that couldn't happen. Okay, let us start today's session. So I think how many are there? Seven. Somebody left, I think. Okay. So let me go to the file. Okay. But before that, let me present. So the entire screen. So I'm sharing the screen. You can see immediately. Okay. Uh, the screen is shared, and I will go to the folder where that is left. With this, let us go to that and response spectrum analysis. Okay, all of you can see this. Hello.
Yes, sir.
Yeah, and we'll start within few minutes. Just let me have it. Okay, in today's session, what we are going to do, we are going with the same exercise, same data, same building, same parameters, but today we'll be going for calculation of base shear and shear at every floor level. So that is a story shear that is to be found, but we are going for dynamic analysis. Previously, we have seen how we can use that equivalent static load method, but then why we are going for dynamic analysis? Because basically earthquake or wind, these are the dynamic activities. And what do you mean by dynamic? Yes, anybody?
Keep on change, which keep on changing.
Keep on changing with respect to time. Okay, so this could be your force. So if I say T, and here let's say this is your force that is applied. Okay, so if the applied force either in magnitude or in direction, if it is changing with respect to time, so time variable with respect to time. See, normally we are dealing with lateral loads, and if I draw a lateral load path or graph with respect to time, you can see that at t equal to 0, it might be something like this, and after some time, you will always find a graph horizontal to x-axis or a time. So this will be constant p, right? So with respect to t, it will not change. So it will be some constant, maybe some 10 kilonewton, 50 kilonewton, whatever the weight of that force or whatever. So lateral once it is applied, so for application, you will see that it varies with time, because you are inserting one brick on another brick, like that. So for the period of 1 to 2 days, it will start increasing. So right now t equal to 0, it is over here, and over the time 1 or 2 days, or let's say for at least 4 days. So for this 4 days time, 4 day, you will see that the load on the beam or any other element is increasing, but once it is final, it will be continuous. That means constant. So this value will not change, and the direction of action will also does not change. It will never be for some time it is downward, for some time it is upward. It is not like this. So that's why we call this as a static, and we have equations of static equilibrium, etc. But what will happen with the time? Now, because of this time, you will see that if u is the deformation, which is with respect to time, then you will see that as the deformation, rate of change of deformation with time will be denoted as velocity. So it will be u dot of t. Okay. And rate of change of velocity with respect to time will find a way as acceleration, right? So u double dot of t. So this is what normally we call it acceleration. This we call it velocity, and this we call it as displacement. In our case, we call it as deformation, a change in the length or width or any dimension. Clear? So once this is coming in picture, this will this will differentiate your equation f equal to sigma f equal to 0. Now you will see that it is not equal to 0. Are you getting the difference? Hello.
Yes, sir.
Earlier we used to say that sigma f equal to 0, because you know that from Newton's law of motion, we know that m times. Now m is not 0, because every element is having mass. As it is having weight divided by gravity will be considered as mass. But always this was equal to 0, because it is the rate of change of velocity, or rate of change of twice derivative of deformation with respect to time. That that was 0, and that's why we say that finally we say that this is equal to 0. Clear? So that is how we find the equation of static equilibrium. But now this is not equal to 0, so I will say that finally it you can find out as is equal to m times u double dot t. Clear? Hello.
Yes, sir.
Yes, sir.
So finally, if you find out this equation just similar to this, you may say that, sir, finally, do you mean to say that sigma force minus m times u double dot equal to 0, u double dot t equal to 0? Yes, that is called dynamic equilibrium. Okay, D'Alembert's principle. If you can go back to your structural dynamics, or I will say simply dynamics, you will see that D'Alembert find this equation that similar to static equilibrium, this is a dynamic equilibrium, and as this m into acceleration, it is called inertia. Inertia. Yes. Hello.
Yes, sir.
Yes, sir.
So this is why we are interested in finding out mass of the structure, because finally you have to solve this equation, and now this equation is not a simple equation. It is a dynamic equation which is varying at every time. So at t equal to any other t equal to 1, it will have some different equation. T equal to 2, it will have different. And that's why this dynamics becomes a little bit complicated. The only thing is that if you can find out the inertia and include the inertia effect, then finally you will see that f minus m dot ut will be equal to 0. So this is why we are finding out inertia effect, and we are relating any dynamic force with that. Now we are going to use that in this, so that we'll find out the uh, way how to find out it, right? So let us go and see. So this is your structure that we are going to discuss. So again, this is the elevational data. Then this is the same data, that is input data for location. Then here same design parameters, because the zone factor or I factor or 13920 are equal to, it will not change. Now this is the only thing that you should understand. See, we are finding out dynamic characters, and as previously I discussed that every building is having its own dynamic properties, and what we have done in equivalent static mode, we have considered only this much mode, this first mode. So we said that the building will vibrate something like this. Yes. And finally, we have calculated that VB, and this VB was distributed with respect to that at every floor. And we said that the deformation is this. That means only this shape, first mode. But actually, this is possible only for degree of freedom equal to 1, right? But building, if you see any building or any structure, you will see that the mass is not concentrated at any one point. So it is distributed all over the floor, and it is distributed all over the height. And that's why we say that finally for some, we are distributing, or we are assuming the mass distribution at floor. Let's say if you are having 3. Now every mass has a degree of freedom in one direction as 1. Okay. So that's why there are 3 masses. So degree of freedom will be 3. And with respect to that, you will find, if you go for dynamic analysis, you will find this as a mode shape 1. Then this will be something mode shape, and this will be something mode shape 3. I'm just pictorially saying, but uh, this mode or this mode or this mode, it is a property of a structure. Okay. And this is found out with the help of free vibration analysis. Okay. How that free vibration analysis is carried out, etc., that is a topic of structural dynamics. Let us say that we have one instrument which will give you the dynamic properties. Okay. So these are the dynamic properties. So we have carried out the analysis for this above said building in our example, and we are considering this as a input for us, which is actually output of free vibration properties of the building for vibration in x direction. Clear हो रहा है?
Yes, sir.
You may ask me, sir, what is this 0.86? Where from you got it? What is this 1.0, 0.904 or 0.716, 0.441? This is the outcome of free vibration analysis with the help of eigenvector analysis. And that you can analyze the structure. And we are getting these results from any instrument, or say we are having some instrument which is giving you the moment you are defining the building, and you are applying the gravity forces, uh, this vibration characteristics are defined, and this will be same for any earthquake. So what we are doing, we are considering now, again, if you are having n story structure, then it will exhibit n different mode shapes. Okay, so this is the mode number one, where you are having time period equal to 0.86. Earlier, we have found that in equivalent static load method, we have found it with some arbitrary or empirical formula, which was 0.09 h or root d. Earlier, we have found it with empirical, some assumed formula based on exercises and based on experience and n number of lab studies, right? So this was that formula, but now we are actually finding out the through its free vibration analysis, and we are getting, so we are not going for this, we are getting actually. So for mode number one, it is 0.86. For mode number two, it is 0.265. And for mode number three, it is 0.145. Clear?
Yes, sir.
Any doubt?
No, sir.
Okay. So this is again input, and now these are the mode shapes. Again, you can if you plot all these are nothing but the uh, what I will say, that relative position of masses with respect to each other in mode number one, mode number two, and mode number three. ये थोड़ा clear हो रहा है? Okay, I will show you that. Okay, let's say this is your building. So 1, 2, 3, and 4. So this is 1, 2, 3, and 4. So this is your roof. Now, at every floor, you are considering mass. So every mass will exhibit with or vibrate with its own frequency. And together, if entire building is vibrating in mode number one with T equal to 0.86, how it will vibrate. So that is the graph that you are getting it over here. So let's say if I say the roof is vibrating with or position with respect to other masses is 1, then this third roof will have zero point 0.9. So I'm writing it over here. Then second floor is having zero point 0.7, and first floor is having zero point 0.4. And now if I join it, I will see this. So this is the relative position of all masses with respect to each other in mode number one. Clear हो रहा है?
Yes, sir. अब clear है.
हाँ. Now let us see what you are getting in mode number two. Again, you have to draw the picture. So let's say, so this is 1, 2, 3, and 4. Now this 1. So let's say it is positive 1. So I will write it over here. So this is 0.216. That means I will write it over here. Then this is minus 701. So I will have to plot it over here. And this is zero point 0.9. So I will have to plot it somewhere here. And then if I draw the shape, I will get a shape something like this. Clear? So this is mode
Yes,
number
sir.
2. See, positive in this direction and negative in this direction. If you reverse, you will get a shape something like this. So positive in this direction, negative in this direction. Clear? So this is
Yes.
a mode shape. That means mode shape will give you the position, relative position of masses when they are vibrating in that mode. Okay. Hello.
Yes, sir.
And similarly about 3. So without investing much time, I will just try to look at. So 1, I will write it over here. Then minus, I will write it over here. Then minus. So again, this is minus. So I will write it over here. And this is 1.1. I will write it over here. And I will draw it. Clear?
Yes, sir.
Yes, sir.
Now this is why we are interested in pre-vibration analysis. ये क्वेरी आया मन में?
Yes, sir.
What the hell this pre-vibration analysis is important when you are going actually for earthquake analysis. Okay, let me tell you. These are the basic characters of the building, and uh, see what is the chance that the building will vibrate in mode number 1? Only when you are having time period of earthquake vibration as 0.86. Okay, is this much clear?
Yes, sir.
क्लियर है? नहीं है तो ना बोला, because see I don't know how much time it will take, but unless and until you understand these concepts, you will never get a belief or confidence in your mind. Many times you may solve the problem, but you will not be a confident. Let's say this is a building. Okay, the building. See, pre-vibration analysis. What pre-vibration analysis is trying to tell you that if the building is vibrated with this time period, it will vibrate like this. If the building is vibrating in this period, then it will show these type of deformation. And if it is vibrating in this mode, then it will vibrate like this. Clear? Hello.
Yes, sir.
Yes, sir.
Yes, sir.
But what is the chance that the earthquake that you're getting and that earthquake is moving your structure with this acceleration? What is the chance that this will? Because earthquake will have bunch of frequencies with him, and with that कभी ना कभी ऐसा हो सकता है कि that frequency may be this, or the frequency may be this, or the frequency may be this, or near to this. Clear?
Yes, sir.
When the frequency will be near to this, it will vibrate with that mode. Okay. So ये clear हुआ?
Yes, sir.
Now,
Yes, sir.
now the second point is that when the building will vibrate in this mode, it will offer least resistance, or I will say in another word, it will deform maximum. क्लियर हो रहा है? सी, किसी चीज को अगर आप लेस रेजिस्ट करते हैं तो क्या होगा? इफेक्ट मैक्स होगा. यस.
Yes,
Yes,
sir.
sir.
Now any other frequency, if the earthquake is not vibrating the entire building in any of these shape, then building will not vibrate. मतलब वहां पे डिफॉर्मेशन नहीं आएगा. If the earthquake frequency is very very away from this. क्लियर हो रहा है?
Clear, sir.
Now that is why we are calculating the free vibration analysis of the building, because we get the frequencies under which the building will show maximum deformation. And now if I know the maximum deformation, and because of that maximum deformation, if I know what is the lateral force that is coming out of that, and if I design the building to stand for that lateral force, am I worried about any force less than this?
No, sir.
And that is why we are using dynamic analysis with free vibration properties of the structure and combining it with earthquake and getting the lateral forces. Clear?
Yes, sir.
नाउ आगे जाएंगे. अब सो पहला काम तो किया, स्ट्रक्चर डायनेमिक्स किया, ये बिल्डिंग का एनालिसिस करने के बाद यू गॉट द मोड्स. नाउ विद द हेल्प ऑफ दिस मोड, what we are finding out. Okay, so this slide is showing you the mode shapes that already I explained. Clear?
Yes, sir.
Now this objective, modal mass and modal participation factor, story shear, base shear by response spectrum method, and scale factor. Right? Now, up till now, you have understood this story shear. ये आपको थोड़ा थोड़ा समझा है, but you're totally unknown with this. Yes, anybody knows this modal mass and modal participation factor?
No, sir.
No, sir.
Okay. And this is okay. We are finding out the base shear with the help of response spectrum. As earlier, we have found out a base shear with the help of equivalent static. So this is clear. This is clear. And these are the 2 points where you are not knowing anything. Okay. Yes.
Yes, sir.
So we'll try to see. I'm not going in mathematical definition. Later on, we will see the mathematical definition of modal mass and modal participation factor. But try to understand it, how it will differ. See, this is your building, and let's say this is your mass, and this is your mass, and there is a earthquake, and it is generating with acceleration uz of t. इट इज वाइब्रेटिंग द बेस. बाकी कुछ नहीं करता अर्थक्वेक. अर्थक्वेक किसी को तकलीफ नहीं देता. वो बोलता है नहीं, मैं थोड़ा सा हिलाऊंगा और निकल जाऊंगा. क्लियर?
Yes, sir.
तो अर्थक्वेक डरावनी चीज नहीं है. वो बोलता है यार मैं क्या कर रहा हूँ, मैं तो सिर्फ बेस हिला के जाता हूँ. अब बेस के ऊपर आपने जो खड़ा किया है ना, वो उसको सस्टेन नहीं कर रहा है, इसीलिए फेल हो रहा. मेरी वजह से नहीं. समझ में आ रहा?
Yes, sir.
सो अर्थक्वेक इज नॉट एट ऑल अ कल्प्रिट. The culprit are the creators of this structure and not allowing the earthquake, or the building is not having a friendship with earthquake. At the moment it is having a friendship, earthquake के साथ जैसे earthquake डांस करता है, वैसा बिल्डिंग भी थोड़ा डांस करेगी. वो निकल गया, बिल्डिंग भी स्टैंड होगी. क्लियर?
Yes, sir.
तो पहले earthquake को डरना नहीं है, उसको सिर्फ समझना है. बस क्या कर रहा है? earthquake is vibrating the base Now, if the base is vibrated, the mass is not at base. This is some h distance, and this mass is at some another h distance. क्या दोनों उसी उसी ढंग से वाइब्रेट करेंगे जैसे बेस वाइब्रेट हो रहा है?
No,
नहीं.
No,
sir.
sir.
Yes, sir.
So it will have a max effect. This will have uh, uh, a lesser effect, etc., etc. Yes,
Yes, sir.
hello. But actually, what is happening? Let's see that there is and you always see that when there is a earthquake in Japan, we do not have any. We can read it through the news only, right? We do not experience, but the people who are there, they will physically experience. They don't have to go and see the TV or newspaper, because they experience. बराबर है?
Yes, sir.
अब जो बंदा क्रिकेट के स्टेडियम में बैठा है, वो तो सामने क्रिकेट देख रहा है ना, तो ही डजंट नीड एनीवन टू एक्सप्लेन दैट अरे वो देखो अभी सिक्स मार दिया, देखो वो बैट्समैन, देखो फील्डर स्लिप आउट हो गया, because he can see. But the person who is not in the stadium, उसे कहां से समझेगा? थ्रू द न्यूज. और कितना समझेगा? थोड़ा कम, क्योंकि see this is very near, so it will have. So if it is having some acceleration, the same acceleration will not be subjected over here. There will be some little different acceleration, that is we call it spectral acceleration. This will have another spectral acceleration, and that also depends upon rigidity, whether the building is rigid or whether the building is flexible, right?
Yes, sir.
Now, do you know the basic difference between rigid and flexible structure? Let us say that this is a complete solid. This is a complete solid filled with uh, filled with concrete material. Okay, and it is subjected to some acceleration, right? It is subjected to some acceleration. What will happen? Because of this acceleration, the entire structure might move up to here. ऐसे ही जाएगा ना? So this may be movement. Yes.
Yes, sir. Yes, sir.
So this is called a rigid body movement, where there is no change in the shape of the body. Only the body is displaced from one place to another. And if it is a vibratory, then this will move in this direction. Then this will come to this. Then it will go to this, and then again it will go to this. Then again it will go to this, and that cycle will go on, right? But there will be no change in the shape of the body. Clear हो रहा है?
Yes, sir.
So that is called a rigid body movement, and it is depending on the rigidity, entire body, whether connected rigidly. Okay. Hello.
Yes, sir.
Now let us say that this is another structure, and this is let's say this is uh, some steel rod, and it is having a mass concentrated over here, and the entire rod is steel rod, and now it is subjected to earthquake with U double dot Z of T. इसका इसका मूवमेंट कैसा होगा? देखो, ये यहाँ पे जाएगा, ये यहाँ पे ही रुकेगा, and finally it will behave like this. इधर जाएगा, there is a movement in the body of the structure, but the mass will be there only because it is rigid. So this will not move, and then this deformation, whatever may be in this direction or in this direction, it is called a deformation. Now, because of base moving over here, but the mass above is stationary, you are getting changes in the shape of the body, and that is called deformation. So this is a flexible structure, and the one is rigid structure. Clear?
Yes, sir.
So in first case, the entire mass was activated and it moved the entire body. Okay, entire mass. In second case, mass was not at all activated, वो अपनी जगह रह गया, वो नीचे connecting body move हो गई, right? So in that case, in this case, mass did not contributed, right? Clear?
Yes, sir.
So there are two choice for the mass, that either it will be getting contributed or it will absent in that motion. So those are the true extremities. So 1 and 2. It will have 100%. So rigid, and this will have 0%. बराबर?
Yes, sir.
बट हम लोग ना इधर रहते ना इधर रहते, तो देयर विल बी सम परसेंट, लेट्स से 50%. ऐसा होता है ना, आपको 100 मार्क्स का पेपर दिया जाता है, आइदर यू
Yes.
कैन स्कोर 100 और यू कैन स्कोर 0, मगर आपको दोनों पसंद नहीं है, तो आप क्या करते हैं? 60% स्कोर करते हैं, 70 करते हैं, कुछ
Yes, sir.
बंदे 80 करते हैं, 0 तो कोई नहीं करता ना.
नहीं, sir.
The same way we are somewhere here. That means percentage of mass getting contributed in the action is called modal mass. अब इसका डेफिनेशन आपको जो करना है करो, राइट? तो मॉडल मास समझ में आया?
डेफिनेशन तो सर काफी मतलब वो कंफ्यूजिंग थी, जब सर कोड में स्टार्टिंग में टर्मिनोलॉजी पढ़ी थी सर आज, तो उसमें कंफ्यूज हो गया था, आपने समझाया तो अब समझ में आया.
अब दोबारा वो डेफिनेशन पढ़ लो, अब वो डेफिनेशन भी समझ में आएगी.
यस सर.
जो पहले आपको कुछ नहीं समझाना, अभी आपको 80% समझेगा, और दोबारा पढ़ लिया तो 100% समझेगा, क्योंकि कंसेप्ट नहीं पता था. ये मॉडल मास क्या होता है? So modal mass is a percentage of mass that is getting activated in any activity. So right now we are having 3 activity: mode number 1, mode number 2, mode number 3. Right?
Yes, sir.
So what is the modal mass that is getting contributed in the activity of mode shape 1, mode shape 2, mode shape 3? That is modal mass. And because of that, what is the factor in terms of force? So this is in terms of kg, and this participation factor is in terms of newton or kilonewton or whatever unit that you are using for force, right? Clear?
Yes, sir.
So modal mass. So with some technique, we are interested in finding out modal mass, and we are interested in finding modal participation factor. क्लियर? तो ये हमारा ऑब्जेक्टिव है. ऑब्जेक्टिव क्लियर हुआ?
यस सर.
So,
हाँ, क्योंकि वो अगर क्या करना है वो ही नहीं क्लियर हुआ ना, तो फिर आगे की प्रोसेस का कुछ फायदा नहीं. कहाँ पे आपको हिट करना है? सो दैट द गोल इज विद द हेल्प ऑफ रिस्पांस स्पेक्ट्रम और डायनेमिक एनालिसिस, फ्री वाइब्रेशन एनालिसिस, जो भी आपको कहना है, you are interested in finding out modal mass and modal participation factor. Clear? Now you can see this clause, just you can read it. Buildings with regular and nominally irregular plan configuration may be modeled as a system of masses lumped. ये हमने पढ़ लिया है. Having each mass having 1 degree of freedom, that the lateral displacement in the direction under consideration. In such case, the following expressions shall hold in the computation of various quantities. The various quantities are modal mass and modal participation factor. Okay.
Yes, sir.
Now we are having 3 mode shapes. So we are going to find out 3 modal masses. Okay, modal mass in K mode, that is first, second, third, or whatever. If you are going for n number of floors, you will be going for n number of modal calculation of n number of modal masses. Okay, so modal mass mk of the mode K is given by this equation. Okay, don't look into this equation, try to understand this. So where you are here, you are having g. भैया ये g का मीनिंग क्या है? एक्सेलरेशन ड्यू टू ग्रेविटी. ओके, पता चला. ये फाई आई के क्या है? मोड शिप कोएफिशिएंट एट फ्लोर आई इन मोड के. अब ये थोड़ा गड़बड़ी है, राइट? उसको थोड़ा बाजू रखते हैं. समझा क्या? उस पर कौन सा सिस्मिक वेट ऑफ फ्लोर आई, ये आपको पता है? हेलो?
Yes, sir.
तो
so
अब यही नहीं समझ में आ रहा है. फाई आई के, दैट इज मोड शिप कोएफिशिएंट एट फ्लोर आई इन मोड के. अब देखते हैं. देखो 1 by 1 सबको लाइन में लाया ना तो सब सीधे हो जाते. सबको एक साथ आप ट्रीट करोगे ना तो फिर वो हंगामा मचा देते एंड यू गेट कंफ्यूज. तो क्या करना है? चल भाई तू बाजू आ, तू बाजू आ. अब कौन बचा? ये इसको देखता हूँ. अब व्हाट इज दिस? फाई आई के मोड शिप कोएफिशिएंट, दैट मींस इट इज अ रेशियो, दैट इज ओके. Floor I, that means how many floors I am having, say n number. So I equal to 1, 2, 3 up to n. In mode K means how many modes I am considering, that I am considering 3 modes. Now our building is having floor number 1 or floor 1, 2, 3 and finally terrace. So I equal to 1 to 4, right? Clear?
Yes, sir.
यस सर.
yes,
Now, what is this mode K? How many modes that we are going to use right now? 1 to 3.
यस सर.
Okay. Now, mode shift coefficient. Okay, ये कुछ रेशियो है, देखते. At floor I. So, at floor 1, it will be phi 1. Okay.
Yes, sir.
At floor 2, it will be phi 2. At floor 3, it will be phi 3. At floor 4, it will be phi
5-4.
4. Now in mode K is 1, 2, 3. So if I am going for this mode number 1, here K will be 1. हो गया phi I K.
Yes, sir.
तो आसान है कि डिफिकल्ट है?
आसान है सर, ध्यान देना है।
एक एक को कोने में लेना है, फिर वो सीधा हो जाता है। बराबर है ना?
यस सर।
सही है
ये
सर।
सब साथ मिल के आए ना, तो ये आपको सीधा कर रहे हैं, क्योंकि सब साथ मिल के आए ना। क्लियर?
यस सर।
So 5ik is not at all a big deal. It is now, if I consider this as 2, then it will be
2.
2. और ये 3 है तो ये 3 होगा, बाकी तो वही रहेंगे ना। Yes.
यस सर।
Now we'll go back to our results that we have found out. ये था ना?
यस सर।
So this will be 511. This will be
2.
521. This will be 531. And this will be 541. Right? So this will be 513. And this will be 543. Okay. So
Yes, sir.
what about this? This will be 532. First I and then K. I is floor and K is mode. Okay. So 5ik is a ratio or coefficient in floor I in mode K, at floor I in mode K. अब क्लियर हुआ?
यस सर।
So,
अब वो डेफिनेशन दोबारा पढ़ते और बोल, अब देखते वो क्या डराती है कि नहीं। मोड शिफ्ट कोएफिशिएंट एट फ्लोर आई इन मोड के। क्लियर हुआ?
yes,
कि
sir.
स्टिल कुछ गड़बड़ है? हेलो?
यस सर।
Okay, now we'll see that. See, actually, we are interested in finding out more mass, modal mass, and that modal mass is a combination of all these. And how it has been defined by our code, or in the, this is not defined by code, this is defined by mathematicians in analysis of structural dynamics. Code has just quoted it from the structural dynamics book. That what you have to do, you have to find out wi, multiply it pi ik, sum all, and square the sum. Okay. See, it's very simple. I will say w1 511 plus w2 512, right, plus w3 513. ये सम हुआ? सम हुआ
यस
कि
सर।
नहीं?
यस सर।
ये सम को मैंने स्क्वायर किया, दैट इज व्हाट दिस।
यस।
अब ये भी आपको तकलीफ नहीं देगा दोबारा। सिमिलरली दिस, कुछ नहीं करना है, अब इसको पहले स्क्वायर करना है, फिर सिस्मिक वेट से
मल्टीप्लाई
मल्टीप्लाई
कर देना।
करना है और टोटल को ऐड करना है, दैट्स ऑल, एंड डिवाइडेड बाय जी। So that is how you are finding modal mass K, right? हेलो.
Yes, sir.
So modal mass के WI phi I K. Okay. Okay. That was a little bit uh, mistake from my side. Actually, see, this is WI phi I K. So K is always 1. I is varying. Okay. So it should be W1 phi 1 plus W2.
512.
No. K is 1. Now I equal to 2. So 2,
Okay.
1 plus W3. Now I equal to 3. So 5, 3.
31.
And K is constant. So this is for mode K divided by G into bracket W1 511 square
Square.
plus W2 521 square. Similarly that. तो ये कैलकुलेट कर सकते हैं.
Yes, sir.
कुछ कुछ बड़ी बात नहीं है और ये हमको करना भी नहीं. हमको सिर्फ ये इसको थोड़ा प्रैक्टिस करना है. ओके. सो दिस इज मॉडल मास. सो मॉडल मास, so each mode will have one modal mass. Clear? So mode
Yes, sir.
number 1 will have one mode mass. And now finally what we are trying to say that so this was your deformation and this was your mode number 1 and this was your mass. हम लोग इसको इफेक्टिवली एक ये तीनों मास को इफेक्टिवली वी आर गोइंग इन 1 mk, that is k equal to 1. Yes.
Yes, sir.
ये सबको मिलके हमने अप्रोक्सीमेटली मॉडल मास निकाला in this vibration. That means whatever may be the total mass of this entire building, if the building is subjected to some frequency for this mode number 1, only this much mass will get activated and it will, due to activation, it will dissipate the energy. Clear?
Yes, sir.
तो जिन्होंने दिमाग लगाया सही लगाया कि नहीं? बिल्डिंग
सही
कितना
लगाया सर.
बिल्डिंग कितना कॉम्प्लिकेटेड है, फिर भी उन्होंने अप्रोक्सीमेट करके बोला नहीं ये पूरे बिल्डिंग में अगर ये वाइब्रेशन को बिल्डिंग डिफॉर्म हो रही है तो कितना एनर्जी डिसिपेट होगा, दैट विल डिपेंड ऑन कितना मास एक्टिवेट होगा. राइट? सो यू विल गेट 3 मासेस. मास को लेके क्या करना है भाई, फोर्स चाहिए ना, बराबर? यस.
यस सर.
So we are not interested in mass. So we are saying that finally, actually, we are interested in design lateral force at each floor in each mode. तो अगर वो बिल्डिंग मोड नंबर 1 में वाइब्रेट हो रही है तो एवरी फ्लोर को कितना फोर्स आ रहा है, मोड नंबर 2 में वाइब्रेट हो रही है तो एवरी फ्लोर कितना फोर्स आ रहा है, और मोड नंबर 3 में वाइब्रेट हो रही है तो एवरी फ्लोर पे कितना फोर्स रेजिस्ट करना है. क्योंकि जितना रेजिस्ट करना है पता चला तो डिजाइन करेंगे ना.
Yes, sir.
So that we are. So design lateral force at each floor in each mode. अब ये डेफिनेशन भी लोगों को ध्यान में नहीं आती, बोलते यार क्या कोड में लिखा है पता ही नहीं चलता, राइट?
Yes, sir.
सो ये कुछ नहीं है, दिस इज अ पीक lateral force, maximum lateral force, and that's why it is called QIK. That means I will be the number of floor and K will be the mode at floor I in mode K. So QIK अगर मुझे मिला somehow, तो मैं बोलूंगा आई कैन डिजाइन दैट बिल्डिंग। होता है ना ऐसा? यस। मेरी टीम में अगर सचिन तेंदुलकर आया ना, तो मैं भी 500 रन एक मैच में करके दिखाऊंगा। रिक्वायरमेंट क्या है? आई मस्ट हैव सचिन तेंदुलकर इन माय टीम। वैसे ही मैं कह रहा हूं, इफ somebody gives me what is the maximum lateral force at each floor इन ईच मोड, अगर किसी ने मुझे दे दिया, तो डिजाइन तो बहुत सिंपल है, आई कैन डिजाइन इट। ओके,
यस
so that QIK, so we are finding out QIK. It is a design matter force. PK is the more participation factor. Okay, we forgot to find out PK. So एक step मैं आगे गया। Yeah, in this we got model
Yes,
mass,
sir.
and then here we'll find, actually we are with the help of mass we will find out a participation factor, and that participation factor is again nothing like just wi phi I k sum divided by wi phi I k square, and then sum and find out the ratio. Again, this is also a factor or ratio. Clear?
क्लियर सर।
Okay, now you know mk, you know pk, आमिर खान वाला नहीं, ये पीके अलग है। Okay, so if you know pk, you know wi, and already free vibration analysis has given you phi ik। अब ये नया बंदा आ गया ak, ये कुछ नहीं, वो पुराना ही है, और फॉर्म बदल क्या है। ak design horizontal acceleration spectrum value as per 6.4.2 using natural period of vibration tk of mode k। तो भाई आपने ये जो निकाला था ना TA,
Yes, sir.
ये TA, अब ये TA की जरूरत नहीं, यू कैन फाइंड आउट T1, you can find out T2, and you can find out
T3.
T3. Actually free vibration analysis has given you this, बराबर?
Yes, sir.
सो इसको यूज करना है और वही स्पेक्ट्रम में जाना है, एंड ऐसे बाई जी निकालना है। फॉर दिस T1 मे बी T2, T3, तो आपको 3 मिलेंगे ना, ऐसे बाई जी?
यस सर।
दैट इज AK। क्लियर?
Yes, sir.
अब देखो, हमें तो कुछ करना नहीं है, सब कुछ तो उसको ही करना है, हम सिर्फ कलेक्ट कर रहे हैं, और फिर भी बोलते हैं सर बहुत डिफिकल्ट है। ओके, सो विल फाइंड आउट AK with the help of 6.4.2, as you know that, and then you are finding story shear forces in each mode QIK। तो इसको जरा थोड़े बाद जाते, so you can find out QIK and then you will find out VIK। अब इसको भी जरा बाद में देखते। अब देखो, कैलकुलेशन ऑफ मॉडल मास एंड मॉडल पार्टिसिपेशन फैक्टर। अब जो आपने कंसेप्ट में सीखा ना, कंसेप्चुअली अबव, वही उसको फॉर्मुलेशन में हमने यहाँ पे पुट अप किया है। क्या किया है? 1 2 3 4 story level I and summation. So for weight, you know that how we have found out 15,600, 4,200, 4,200, 4,200, 3,000. ये तो हुआ।
Yes, sir.
अब ये बंदा तो आपको मोड 1, देन मोड 2 एंड मोड
Mode
3,
3.
तो फ्री वाइब्रेशन एनालिसिस ने दे दिया। ओके, क्लियर? हेलो?
Yes, sir.
यस सर,
Now
क्लियर।
what I am going to find out, I am going to find out this WI phi IK. That means I have to find out phi IK multiplied by WI. That is what I am doing over here. So 4,200 multiplied by 0.441 will be this. Then 4,200 multiplied by 0.716 will be this. Then 4,200 multiplied by 906 will be this. And this 1,000 multiplied by 3,000. This is not 1,000, 1.0 multiplied by 3,000 will be this. तो मैंने ये निकाला, इसका सम किया, ये निकाला, मतलब ये मिला मुझे WI phi I के सम मिला ना।
Yes, sir.
तो उसका स्क्वायर कर सकता हूं मैं। सी, अगर कंसेप्ट क्लियर हुआ ना तो ये सिस्टमेटिकली करना बहुत आसान है। कंसेप्ट नहीं समझा तो ये वो मुश्किल लग रहा है। ओके, तो यहाँ पे मैंने क्या किया, WI phi I के, और यहाँ पे मैंने और एक कॉलम किया, वहां पे क्या किया, phi I के, एक्चुअली दिस इज phi I के। ओके, phi I के, तो यहाँ पे मैंने phi I के का स्क्वायर किया और 4,200 को मल्टीप्लाई किया, जो आया वो यहाँ पे लिखा। सो phi I के स्क्वायर मल्टीप्लाइड बाय 4,200 यहाँ पे लिखा, 0.904 मल्टीप्लाइड बाय दिस यहाँ पे लिखा, एंड 1 स्क्वायर मल्टीप्लाइड बाय 3,000 यहाँ पे लिखा, समेशन किया, यहाँ पे लिखा, तो ये मिला। राइट?
Yes, sir.
तो फाइंड आउट द मास, मॉडल मास इन मोड नंबर 1। सी 11,656 square divided by 9,402 multiplied by G. I am not using value of Z because finally I want that modal mass. Okay, so you can see that 14,450 kilonewton divided by Z, that is, this is the mass. So this is the seismic mass getting activated in mode number 1, right?
Yes, sir.
Now, if I want to find out a ratio, I can simply find out 11,656 divided by 15,600. Not this 14,450. That is the seismic weight divided by total weight. So that is 92.6. That's why we are not using G over here. We are just saying G. That means this is seismic weight getting activated. Divided by G will be seismic mass. Clear?
यस सर।
So the building is having seismic weight equal to 15,600. Out of that, in first mode, the building is getting the activated weight is 11,656. So if I find the ratio 92.6, so the 92.6% of total seismic weight, or now you can say, if you are working in percentage, you can say seismic mass is getting activated only in mode number 1, right? Clear?
Yes, sir.
Conceptually
Yes, sir.
try to understand it. Forget about the what figures are there, figures का मैं ज्यादा महत्व नहीं देता हूँ. इसका इंटरफियरेंस क्या निकाला मैंने? बिल्डिंग इज हैविंग सम seismic weight and the building is subjected to lateral movement due to earthquake, and because of that, if the building is vibrating in mode number 1, 92.6% of total seismic weight will get activated. Clear?
Yes, sir.
Yes, sir.
That is the inference that you can find out. Forget about other calculations. अगर वो calculations का inference अगर नहीं निकाला ना, तो you don't have any not understood anything. Okay, now अगर मैं ऐसा statement करूँ, as I am interested in finding approximate shape solution, I am not interested in these shapes. तो भी मुझे कितना परसेंट मिलेगा? 92.6%.
Yes, sir.
तो उतना हैप्पी है ना? And that's why most of the time in old days people do not go for dynamic analysis. वो और ये भी ये whatever that t equal to 0.86, वो आपका t equal to 0.09 आया, राइट? और उसके हिसाब से आपने ऐसे बाई जी वगैरह लगा के किया, तो दे यूज टू फाइंड आउट हायर seismic weight. Okay, they used to find out entire seismic weight, and with that they just go for fundamental analysis with this, and they find out, and their accuracy was more than 90%. Then why we are going for dynamic analysis? The only thing is that whatever assumption that you are using in equivalent static load method, they are best with assumption that your building is regular. You are having vertical irregularity as well as plan vertical symmetry, plan symmetry, as well as symmetry in stiffness, as well as symmetry in mass. And if you see older structures, they were simple structures with the geometry defined, and yes, they were definitely good structures, but they were not going for any complicated things. They make the things simple. But now we are doing complicated structures where there is no regularity. Now, when see, if you are having building something like this, or you are having building something like this, ये होता है ना ऐसा?
Yes, sir.
Yes, sir.
So you just cannot go with assumptions, because that may give you unpredictable behavior, and actual behavior may be different. That's why, and right now we are having a lot of instruments for our help. So we are going for dynamic analysis, and we say that if the building is subjected to more than one mode, why we are going for effective static load method, equivalent effective static load method, we can go for dynamic analysis. And let's see what happens if somebody goes for mode number 2 and mode number 3. अब देखो यहाँ पे क्या हो रहा है, ये रिजल्ट लिए phi I k,
Yes,
whatever
sir.
has been given by free vibration. This multiplied by the 4200 was marked over here. Then this multiplied by 4002 marked over here. Same process was carried out here and here. And now you can see this 2.905 square divided by this 8.822 which is coming out to be 957 kilonewton divided by G. Now, 957 divided by 15,600 is coming out just 6.1%. Now, if the building is not vibrated in first mode, but it is vibrated in second mode, only 6% mass will get activated. तो आपका एक्यूरेसी 92 से ना ये समथिंग 98 हो गया, राइट? अब थर्ड मोड में जाने के बाद इफ यू फाइंड this, you will get 1.366 square divided by 11,620. You are getting 161 divided by 15,600. You are getting 1%. तो फोर्थ मोड में जाने के बाद क्या होगा? Might get 0.5% because now 100% mass is getting activated, right?
Yes, sir.
Clear हो रहा है? But there will not be always magnitude or figures like this. Many times in your first mode, you might see that only 70% mass is getting activated. That means 30% energy is not dissipated. So it may dissipate in some other way. And that's why you have to go for mode number 2. You have to go for mode number 3. And code says that how many number of modes. Let's say your building is regular, but it is 13 story. How many modes you should consider? Each mode for each floor. One mode for each floor. So you can say that for X vibration, you will go for 13 story, 13 modes. For Y vibration, you will go for 13 modes, right? So 26. Now, is that 26 number of modes are required? Because basically every building is having n number of mode shape because there are n number of masses. So you can analyze for any number of modes, but is that required? Now that is discussed over here in the codal provision. Code says that you have to consider those many mode shape until your modal mass contribution up to that mode, including and previous, up to that summation of all modal masses up to that mode and previous shall not be less than 90%. So that is what code says. That means code says that 10% mass you may ignore safely. Clear? Yes.
Yes,
Yes,
sir.
sir.
अब देखो मोड्स टू बी कंसिडर्ड. अब ये डेफिनेशन पढ़ लो 7.8.4.2. The number of sum total of modal masses of all modes considered is at least 90% of the total seismic mass. इतना ही पढ़ लो. इसके आगे missing mass correction beyond 33%. If modes with natural frequency beyond 33 Hz are to be considered, modal combination shall be carried out only for modes up to 33, and the effect of higher modes shall be included by considering missing mass correction procedure. ये आगे ज्यादा काम करना है ना आपको एक में, उनके लिए मैं कहूंगा if you are happy with your codal permission that you can go up to this 90% of seismic mass. ये मिसिंग मास के चक्कर में मत पड़ो, और जिनको पढ़ना है उनके लिए मैं अलग से कुछ किताबें बोलूंगा, देखना पड़ेगा. तो then you will have to go for Fourier analysis and everything. Then don't say that सर वो मैथ थोड़ा कच्चा है, फिर इसको छोड़ दो. Because if you see 33 hertz and higher frequencies, that is That is not a character of the earthquake. A rare earthquake goes to that, and lower frequencies only will make effect. See here, let me go back. See here, mode number one is having time period of 0.86, or let me go back so that you will understand. See, mode number one is having time period 0.86, means it is maximum time period and lower frequency. बराबर ना? Yes, because 2 T is equal to 2 pi upon omega, which is circular frequency. Or if you consider frequency in hertz, T is equal to 1 upon F. अगर T higher है तो F में lower होगा ना?
Yes, sir.
Okay, and you see that lower frequency itself is sufficient for your analysis. You need not worry about this. And earthquake or buildings are always going for effect of earthquake on building is always under lower frequencies. So the frequencies which are higher than 33 hertz, 33 hertz, ये मैकेनिकल इंजीनियर्स के लिए लगता है वो वेरियस आरपीएम, हायर आरपीएम को मशीनरी वाइब्रेट करते हैं ना, तो that is their field. Of course, that doesn't mean that you cannot read that, but there is lot of ample literature is available, but that will not help you in civil engineering. That's why I will say that ओके, कोर्ट ने भी वैसे आपको बोला है ना 90%, भैया 90% मास दे दो एंड ओनली अप टू 33 हर्ट्ज पे रुक जाओ. If anything is beyond 33 hertz, then that missing mass correction will be applied, and that missing mass correction is with rigid body movement and all that. But don't go into that. So I will say that this modes to be considered, ये आपको सिर्फ यहाँ तक ही पढ़ना है. ये मिसिंग मास करेक्शन आपको इतना ही समझना है कि ऐसा कुछ प्रोसीजर है जो 10% मिसिंग मास हो रहा है ना, उसको एक करेक्टिव एफर्ट से इफेक्ट को कंसिडर करते हैं. देयर इज सम प्रोसेस, इतना ही समझना है. और डिटेल में समझना है तो बाद में बात करेंगे, अगर किसको समझना है तो. यस, हेलो,
यस सर.
समझना है कि
नहीं सर, इतना इनफ है.
राइट राइट.
सर ये मॉडल पर एक बार एनालिसिस करवाएंगे ना आप?
क्या?
ये जितना आप बता रहे अभी मॉडल पर अप्लाई होगा ना?
अरे तो सब मैं वही तो पहले सेशन से बोल रहा हूँ. वी आर गोइंग टू कवर ईच एंड एवरीथिंग. एक ही दिन में करूँ क्या?
नहीं सर, अभी इतना काफी है. अभी हैंग हो जाएगा फिर. अभी मैं इसको रिवाइज करूंगा.
इसीलिए हमने टाइम लिया है ना. अब देखो, अब क्या हुआ, पहले कुछ नहीं समझता था, इसीलिए आप बोलते थे मरने दो यार, क्या जरूरत नहीं है. अब थोड़ा थोड़ा समझने लगा है तो इंटरेस्ट बढ़ रहा है ना.
यस सर.
तो
Yes, sir.
यस, दैट इज व्हाट वी एम. क्योंकि वी आर नॉट also not hoping that you will become expert just after finishing our sessions, but at least जो पहले आप डेयर ही नहीं करते थे ना, वो दरवाजा खोल के अंदर घुसने का, बहुत अंधेरा है यार, डर लगता है. अब आपको डर नहीं लगेगा, आप अंदर घुसेंगे और फिर बोलेंगे यार यहाँ तो बहुत अच्छा है. राइट?
यस सर.
ओके, सो let us go into that. We are just killing your fear, और कुछ नहीं.
आज के लिए इतना ही रहने दीजिए सर. हैंग
या
कर रहा है अब.
यस,
अब हैंग आज के लिए इतना ही रहने दीजिए.
अरे भाई मुझे और ओके
सब
तो एक्चुअली बाकी थोड़ा सा है बट ठीक है बट क्लियर हुआ कि नहीं?
क्लियर हुआ है
क्लियर
सर।
है।
एक बार और पढ़ूंगा तो और क्लियर हो जाएगा।
नहीं अभी अभी क्या करना है सी व्हाट यू हैव टू डू यू हैव टू गो थ्रू ऑल दोस पीपीटीज go through that equivalent static load method ppt then go through this response spectrum ppt. We have already given all this ppt to you
यस
यस सर।
and uh, go ahead with that and then after the end of tomorrow's session tomorrow we are going in continuation because वो कल वाला आज लेना पड़ा मुझे okay
ओके सर। ओके
so
सर।
यस
tomorrow
सर वी
also
कैन।
yeah yes
यस सर।
yeah so tomorrow also at 7:30 we'll continue this response spectrum and then finally we'll find out the and we'll compare this response spectrum result with our equivalent static method and we'll see what code has to say on it and then we'll go for I think for a few sessions you will be tied with Anil sir and then we'll go for additional things but we'll plan it but during this I expect all of you to go through all previous recorded sessions and so that get your knowledge updated have a practice with response spectra I mean uh, modeling
यस सर।
uh, any structure and come with queries. मैं हमेशा वही बोलता हूँ क्वेरीज लेके आओ तब मुझे पता चलता है ओके
ओके
यस
सर।
ओके एनी क्वेरीज एनीबॉडी यस निकुल कुमार यस यू वांटेड टू आस्क मी समथिंग
No, sir, not yet, sir.
ओके
Tomorrow
ओके
I'll ask you, sir.
या नो प्रॉब्लम एनीबॉडी मसरूर जहान और सुलेखा मैडम एनीबॉडी इफ you you want to ask me any query you can yes
एक्सक्यूज मी सर।
yeah Samir
सर वो इम्पोज लोड से एक क्वेरी थी सर उसमें कोड में सर दे रखा था कि एक टेबल में कि नंबर ऑफ फ्लोर्स और उसमें सर रिडक्शन इन परसेंटेज रिडक्शन इन इम्पोज लोड करके था।
okay
तो
so
सर वो चीज जब
actually that
हमने
yeah
अप्लाई किया था
yeah
तो उसमें वो चीज कंसीडर नहीं हुई थी शायद, तो वो एक डाउट था कि करनी है या नहीं करनी
right
वो
right
चीज।
right okay let me tell you that that is not for analysis पहली बात when you are going for design of columns okay
यस सर।
so at the time of design of column see what happens code has considered that reduction when there are number of floors see ground floor agar if you are designing a ground floor column and every floor you are saying that maximum considered live load maybe 2 kilonewton 3 kilonewton as per your structure whether it is
यस
commercial or whatever else so let's say residential and you have applied 2 kilonewton at every floor and you have found out the results analysis करने के बाद you found the axial force you found moments at ends of the column and now you are going to design the column clear
यस सर।
now that is the maximum force or maximum response of ground floor to the loading probable applied loading but what is the probability that entire floor will be always heavily loaded with live load see dead load तो होगा ही ऐसा कुछ नहीं होगा
यस सर।
हाँ but live load हो सकता है you are having parking at 2 floors then you might have hotel at 1 floor then there will be residential every floor to its maximum of whatever 2 kilonewton or 3 kilonewton the possibility of all floors simultaneously uh, loaded with their max is very rare.
Yes,
बराबर?
sir. Yes, sir.
And
Barabar.
that's why code says that whatever we are designing, actually it needs a reduction, and that is that reduction factor. Whatever you are saying, 0.9, 8, 7, 6, 0.5, all that. So that codal provision is for your design of columns, and that is only for design of columns. Huh? It is not applied to design of beam and slab.
Yes, sir. Yes, sir. कॉलम पे है वो नंबर ऑफ फ्लोर्स और
Yeah,
परसेंटेज रिडक्शन.
yeah,
यस सर.
yeah, yeah.
कॉलम.
Right. When we will go for design of columns, we'll talk about that. But
हाँ सर, वो ये
you
डाउट
are
थी कि
asking me
डिजाइनिंग या
early.
एनालिसिस में कंसीडर करना है. यस सर.
No. That is not for analysis. That is for design. Design of
ओके
ground
सर.
floor columns, design of first floor columns, design of middle floor columns, and that reduction depends on number of floors above the particular level of columns you are considering. Let's say I am
यस.
designing roof columns, the columns which are supporting roofs. Then there is no scope for any reduction. But let's say I'm going one floor below. Now I'm designing the columns one floor below. So I'm having two slabs. Okay.
यस सर.
What is the possibility that both the slabs will be subjected to maximum loading? Maybe. So that's why code says that only 10% reduction हम allow करेंगे भैया.
यस सर.
Right?
यस
Then
सर.
when you're going one floor below, now there are three slabs that floor column are subjected. They are resisting three floors above. Then code
यस.
says that okay, अब you can consider 20% reduction. That's why that is for a design. So it has nothing to do with analysis. बहुत सारे लोगों को एक तो पता नहीं है, और जिनको पता है वो तुम्हारे जैसे कंफ्यूजन में आते हैं और बोलते हैं नहीं नहीं यार ये एनालिसिस नहीं, वो एनालिसिस के लिए नहीं है, दैट इज फॉर डिजाइन. और अगर क्लियरली वो कोडल प्रोविजन पढ़ लेंगे ना, तो इट इज क्लियरली सेइंग दैट व्हेन यू आर डिजाइनिंग अ कॉलम्स, there could be a load reduction, live load reduction for design of column under consideration based on number of floors it is supporting.
यस सर.
अब क्लियर हुआ?
अब क्लियर है सर.
अब कंफ्यूजन नहीं होगा कभी.
यस सर.
बट ये ऐसे ही क्वेश्चन लेके आओ यार, तुम्हारी वजह से बाकी लोगों को भी समझेगा. पता नहीं बाकी लोग क्यों नहीं पूछते. यस एनीबॉडी? यस अविनाश?
नो क्वेश्चन सर.
अरे कम विथ क्वेश्चन. नेक्स्ट टाइम अगर क्वेश्चन के साथ नहीं आया तो मैं अलाउ नहीं करूंगा.
ओके सर.
क्लियर?
क्लियर सर.
हाँ, ओके ओके.
मैं एक्चुअली मैं एक प्रोजेक्ट पर अभी काम कर रहा हूँ, वो फाइनल हो जाएगा फिर मैं पूछूंगा G+7 का सर, इसलिए.
हाँ कोई बात नहीं. मैं ऐसे ही बोल रहा है, ऐसा कुछ नहीं. यू आर ऑलवेज वेलकम. और मैं किसी को, मेरी तरफ से मैं किसी को
नहीं, जब
नहीं कर.
क्वेश्चन तो अराइज करना ही है, लेकिन लास्ट में अभी नहीं, मैं उसको कर लूँ तब.
ओके ओके कोई बात नहीं. यस यू कैन विथ योर टाइम. एनीबडी? बट आई या सुलेखा जी वांटेड टू आस्क मी समथिंग.
Yes, sir. Could you explain once again that percentage portion, percentage mass participation you told in mode 1, mode 2, mode 3? That portion, could you please explain once again?
Okay, so you want it somewhere here.
From that table.
Table. This.
Yes. Here.
See, actually, this is confusing only because code says percentage seismic mass percentage, and here we are talking about weight. That's why thoda confusion. Why the confusion is there? You can see if I'm getting this value. Okay, So this is my total mass which is getting activated in mode number 1.
Okay, sir.
Clear? So how much it is? Let's say 14,450 divided by G. I'm not including the G equal to 9.18. I'm keeping it as G, and I'm
Okay.
saying that this is in kilonewton. So that's why I'm saying instead of seismic mass, I'm saying seismic weight. Now this is what, this is my total seismic weight, right?
Yes, sir.
Yes. So that is 15,000, 1,600 or 600. Now this is again, if it is divided by G, then this G and this G will get cancelled, and finally I will get this value 92.6. So 11, see, this 14,450 divided by 15,600. I'm
That
getting,
means it is comparing with the static method.
no. See, calculation of seismic weight is same in equivalent static as well as in dynamics. Right now, we are not comparing anything with static. Later on, we will be comparing that in tomorrow's session. I will explain you where now we are comparing the results of dynamic analysis with results of equivalent static. Right now, we are just focusing that this is the total seismic mass. And why I am saying mass? Because it is divided by G.
Yes, sir. Okay. So in this method, this weight, seismic weight calculation is same way. I mean,
Yeah, yeah,
same way we are
yeah.
calculating, no?
Calculation of seismic weight
Weight is same.
is independent of any method. So
Okay.
you can use it in equivalent static load method as well as in calculation of seismic weight in dynamic analysis.
Yeah. Okay. So that means these percentages are means according to seismic weight and seismic mass in each mode, right? This
Yeah,
percentage,
yeah.
each
See,
one.
when you are finding a percent, you can divide seismic weight by total weight.
Yes.
I mean, seismic weight activated in mode number 1 divided by total seismic weight acting in applied calculated by your calculation of seismic weight.
Yes. Okay. Yes.
When you are comparing mass, then you will have to find out the seismic mass, and that is getting activated in mode number 1 divided by total seismic mass. Now see, 15,600 is your seismic weight. If I
Weight. Okay.
divide it by G,
G.
it will become seismic mass.
Mass. Yes. Okay.
So now this is seismic mass and this is also total mass.
Yes. Okay.
Okay.
Okay, sir. Okay.
Yeah.
Now
So
understood.
now if I divide this by this, that means this G will be cancelled out with this, and I will get 14,450 divided by 15,600.
Okay, sir. Now
Yeah.
it's okay.
Yeah. Yes. Anybody. If see, don't keep the doubts with you. वो आपको डराएंगे रात में. Yes. हेलो.
Yes, sir.
तो आप रात को डरना चाहते हैं तो आई डोंट माइंड, अगर नहीं डरना चाहते तो वो डाउट को भगाओ. पास इट टू मी. ओके. So this is how I can deal, but it is up to you. Yes, केतन अकोलकर. अरे मराठी माणूस माग पडायला लागलाय.
No, sir.
शहाजी.
ओके सर, ओके, ठीक.
अरे ओके ठीक नाही चालणार रे, विचार ना बाबा. ओके ठीक है, थोड़ा थोड़ा काम करो
हाँ सर.
और क्वेश्चन क्रिएट करो.
यस सर.
नहीं तो दूसरों को क्रिएट करने के काम पे लगाओ और वो क्वेश्चन अपना समझ के मेरे पास भेजो, मुझे तो नहीं पता चलेगा ना वो आपका है या किसी और का है।
ठीक है सर।
हाँ, but start creating the query. See, that is the way you can learn.
यस सर।
Yeah, and जब तक आप मांगेंगे नहीं ना, भगवान आपको देंगे नहीं,
देंगे।
बात छोड़ो।
यस सर।
तो मांगना सीखो। अरे ये देखो अविनाश और समीर, ये पहले दिन से मांगते तो उनको मिल रहा है ना।
यस सर। यस
यस अविनाश,
यस सर।
मांगना पड़ेगा।
यस सर।
यस सर बिल्कुल।
और
प्रसाद सर, प्रसाद में नहीं मांगे तो देगा कौन? प्रसाद तो मांगना पड़ेगा।
मांगना पड़ेगा। नहीं, दैट इज द लॉ ऑफ नेचर। सी, मैं हमेशा लोगों को ये बोलता हूँ कि आई डोंट नो व्हाई वी डू नॉट फॉलो द लॉज ऑफ नेचर। अगर जिस दिन आप लॉज ऑफ नेचर फॉलो करना शुरू करेंगे ना, आपके जीवन के मोस्ट ऑफ द कॉम्प्लिकेटेड चीजें निकल जाएंगी। यू विल स्टार्ट लिविंग हैप्पीली। जो 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 रूल है नेचर का, फॉलो करो। नेचर बोलता है भैया आपको कुछ चाहिए तो आपको मांगना पड़ेगा, तो मांगो ना। नहीं मैं नहीं मांगूंगा, बिना मांगे मिलना चाहिए, नहीं मिलेगा, फिर आप दुखी हो जाएंगे। क्लियर?
ओके सर।
या ओके। सो विद दिस I will conclude today's session and will meet tomorrow, not day after tomorrow. Tomorrow at 7:30.
Yes sir.
Okay.
Okay. Good night, sir.
Good night.
Good night, sir.
Thank you, sir.
Good night sir. Thank you sir.
Thank
Good
you
night, sir.
and good night.